Dr. Esther Trufan, and in this video, I'm going to demonstrate a method by which we can determine the hydroxide ion concentration in a solution or even in a heterogeneous mixture. For this experiment, we're going to use a heterogeneous mixture that we created by dissolving 2 grams of calcium chloride in a saturated calcium hydroxide solution. And here we have that mixture. We're also going to use an indicator, which in this case is phenolphthalein. And whenever we use an indicator, usually it's a sign that we will be doing a titration that involves solutions or mixtures that are clear or colorless. And the indicator will help us give it an endpoint to the titration. For our titration, we will be using a stand, a burette holder, and a burette. This burette has been charged with an approximately 0.05 molar KHP solution that we prepared earlier. And to place our analyte and get it ready for the titration, we're going to use an Erlenmeyer and a graduated cylinder because we will need to know the exact volume of our analyte. So in the first step of our process, we are going to measure out approximately 20 milliliters of our mixture. It is a little bit below that. It is 19.2 milliliters. We will transfer this into our Erlenmeyer. Then we're going to add 1 or 2 drops of phenolphthalein. This will turn its color to a very deep magenta or fuchsia. Next, before we begin our titration, we need to record the initial volume of the KHP solution in our burette. So we are going to lower the burette so that the meniscus of our solution is at our eye level. In my case, the initial volume is 1.02 milliliters. Now we raise our burette a little bit higher, and we determine which of our hands does which activity. One of them is going to swirl the Erlenmeyer, and the other one will control the valve. For me, I rely more heavily on my right hand, so I'm swirling with the right and monitoring with my left. I will stop the titration when my solution becomes very faint or completely colorless. And I'm going to stop my titration here because it is quite a faint pink. I could add maybe 1 more drop. And now I am ready to record my final volume. And my final volume is 27.41 milliliters. From the volume and concentration of my approximately 0.05 molar KHP solution, I should be able to determine the hydroxide ion concentration that was in my heterogeneous mixture. The other thing that I would like to point out here, that there is a little bit of cloudiness to this solution, but not nearly as much cloudiness as there was in the original one. So this may give you a hint as to which kind of hydroxides or calcium hydroxide the KHP acid is able to react with.